GMAT all day.
Even though I do think of overlapping set questions as being easier than some of the other types of questions on the GMAT, I do a little fist pump in my head whenever I recognize that I have a overlapping set question. But even though that is the case, it is important still that you do not think of overlapping set questions as simply being where you set up a table, plug in the numbers they give you, and then have the table spit out the right answer for you. It is not a magical table. Sometimes you do have to use judgment, and that is why I always say that you just want to think of the table as a way of organizing information. It's a way of organizing information so that you can translate the information from words into algebra or into equations, and that is the real goal. And it will not always be the case that you can fill in every single data point into just a single box in the table. And so you want to figure out how to incorporate that information into your overall plan so that you can use it to solve for whatever they are asking for. So let's take a look at a problem that is an overlapping set problem, but requires a little bit of judgment and interpretation how you want to approach it. On a certain flight, passengers were offered premium seating and premium meals as optional add-ons. 10% of the passengers purchased premium seating, half of whom also purchased premium meals. If 3 times as many passengers purchased premium meals as purchased premium seating, sorry, one more time. If 3 times as many passengers purchased premium meals as purchased premium seating, and 130 passengers chose neither option, how many passengers purchased just one of the options? So let's start with the question here. There is no single box for the thing they're asking us to solve for. The number of passengers that just purchased one of the options. So we're going to have to think about how do we want to set this up so that this is what we are solving for. And so one thing, when I get a question like this, where they're throwing a bunch of numbers at you and a bunch of figures at you, my first time through, I don't really pay attention to what those numbers or what those percentages are. In any sort of complicated word problem, all I'm doing is trying to understand the scenario on my first pass reading it. I can always go back and sort out the numbers. And so as long as I just understand, okay, I have a flight and there's 2 add-ons you can have on a flight. And so this is an overlapping set question where our groups are premium seating is one of the options, and then the other one is premium meals. And so then every person has the option. They either do have the premium seating or they don't. So, and everyone also can purchase the premium meals or doesn't get the premium meals. And so that is all I am looking for on my first pass through. So I got a flight with these 2 options. Everyone either purchases the option or doesn't purchase the option. And between those people, every single person on the flight should be represented. So now I can go back and start sorting out the numbers. So 10% of the passengers purchased premium seating. So that is this guy here, total premium seating. So right here, because I notice I have a discrete number here, so I can't just fill in my percents as if they're actual numbers. So I got to say I got some number of passengers, T, and 10% or 0.1 T got the premium seating, which means 90% or 0.9 T did not get the premium seating. So 10% of the passengers purchased premium seating, half of whom, so half of these people only, not half of all my passengers, half of whom also purchased premium meals. And so 0.1 T, this is 1 over 10. And so half of that should be 1 over 20, which is also 0.05 or 5%. This here will be 0.05 T. And so if half of these people got the premium meals, half of them did not get the premium meals, we got another 0.05 T here. If 3 times as many passengers purchased premium meals as purchased premium seating, so we're talking about all of our premium meal people, and that should be 3 times here. So if this is 0.1 T, this should be 0.3 T, or 30% of my passengers, which means 70% of my passengers did not get the premium meals. And 130 passengers chose neither option. So that is our discrete value that we were given, and that is this box here. No seating, no premium meals, and 130 passengers chose that option. And so how many passengers purchased just one of the options? So I'm going to say, so what are they asking for? So there are 2 ways you can purchase just one of the options. It's either meals but no seating, or seating plus no meals. And so if I put a X here, we'll say this here is Y. We're sort of looking for X plus Y. And now we can say, okay, well, we have our Y. Our Y, I already said, is equal to 0.05 T. So we're looking for X plus 0.05 T. Now, so if I can get my Y in terms of T, it looks like most of my boxes are in terms of T. Can I get my X in terms of T? And it looks like I can, because if 0.05 T is here, 0.3 T here is in my total meals. This X must be equal to 0.25 T. So X plus Y is really 0.25 T plus 0.05 T, which is just 0.3 T, is what I'm looking for. So if this were a data sufficiency question, all I would care about is knowing that I could find T, because that is what I'm the key to my question. It's not data sufficiency, so it's not enough to know I can find T. I actually have to find it. I mean, I have to remember T is not my answer. 0.3 T is what I'm looking for. So can I get an equation where I can solve for T? And it looks like I can, because if this here is 0.25 t, this box here should be what? 0.65 t, because it's got to add to 0.9 t. So 130 is equal to 0.65 t. So again, remember, I'm going to solve for t here. That is not my answer, though. My answer is going to be 30% of t. That is why when I figure that out, or when you figure that out, you want to make sure you box it off, star it, do whatever you have to do to remember that 0.3 t is what you were looking for. So 0.65 t is equal to 130. Actually, let's give myself some more space. So what is 0.65 t? So 65 over 100 times t is equal to 130. What does this simplify to? If I divide by 5, this is 13 over 20. 13 over 20 t is equal to 130. So t is equal to 130 times 20 over 13. So 130 over 13 is just 10, so t is 200. I got 200 total passengers on my plane, and then we won't do this, but because everything in our matrix is in terms of t, I could have filled out the entire matrix. We're not going to do that this time, like we did last time. So here, we'll just skip right to what we're looking for. 0.3 t should be 3/10 of 200. 200 over 10 is 20. 20 times 3 is just 60 passengers who got either the meals with no seating or the seating without the meals. And A is the answer.